Okay, I believe this is the 12. It has two wires coming out. The black one goes there, that's the ground, and then this one wraps around over to here. So I'm going to go ahead and cut them and leave a little bit of the insulation for now. I can cut them off later. And I'm going to jump the capacitor across that standoff there. I might even, do I have enough slack? Yeah, I might have enough slack to get that standoff out of there and solder on it and then screw it back on. Well, I got that capacitor in there on that strip right here, and he's tied on this strip, so he's really good in a good place there. Not going to cause any issues. These three, which replaces the three in that can back there, which are these wires I got numbered, I placed up here. Put a screw in here. There's plenty of space on the side of this box, and you can see they're well below the bottom, so they're in a good spot. I just bent that one up so it's a little easier to read the value. I couldn't put it the other way because I needed the ground on that side, but the other two you can read the values. And so on the big guy I got the red wire. The black is common for all three capacitors. The yellow is the 8 microfarad. Yeah, and I believe so. Yeah, and the 22 mic, which has some shrink wrap on it so it doesn't short out. Actually, the 22.2 is the yellow and the white is the 8. Because it's a lower voltage. And so, yeah, they're in there, and they're ready to be wired in. And then I could do a power-up. I've got the tubes, they came in. Once I get these in, I can gently do a power-up before I change all these caps and just see what we got, you know. And I'm sure it'll be fine. Then I'll go ahead and change these caps once I know that everything's okay. I'm pretty sure everything is. The transformer tests fine. It is a replacement transformer that somebody changed out at some point. There are some capacitors that don't seem to be like they belong here, for instance this one. And you know, they were added later. The bar resistor, power resistor up there of course went bad. They always do, so they put these power resistors in there. I need to check the values on them and make sure they're fine before I connect to that mess. And I might even try to tighten that up some. I mean, it's fine because this blue power resistor is down on the lug of the ground here. It goes to ground. And these two, if they test good, though they're in parallel, I don't really particularly care for that. They're not bad. They're both rated at 25 K ohms in series, so that would be 12.5 K. I haven't really looked at them till now, but let's take a look on the schematic. And that would be, yeah, that would be about right, because these are 11 K. So 12.5 K would be fine here. And then this one is probably was still good when they added these. I might just take all this out. And if these are dead, if this resistor is totally dead, I might just, and these are good values, they're good resistors if the values are still good. That paper don't matter. The other one fell off. And they should have taken them off when they put them on, but they wanted them to be obvious that they were very good resistors. There's Continental certified resistors, and we'll check them. And then this is just an air core power resistor there, 10K, which again would be fine to replace an 11. So if this power resistor is dead like I think it is, I'll just run these from I loop to I loop rather than the way they are, just dangling here. I mean, that's not bad. It's really tight. So they may be fine. I'll decide when I get in here to change these wax caps if I need to mess with them. If the values are right, I won't need to. One of these wires will go right to this here. So, just connect right there, and that'll also stabilize it. So, we'll see. But I need to make sure the values are right before I do that. So the next thing is to go ahead and wire these in. I just put them on that strip, tie strip. So, there you go. I'm getting there. Thanks for watching. All right, well, here's what I found out so far. I need to change these capacitors. I'm not getting much sound out of the speaker. I get a little bit, but it's just static, and it's only when I turn the controls here. Basically, there's nothing. The radio is dead. This guy here, these are shot. These are worn out. This one was inside the cabinet. I just found it a while back. And this one was inside the bottom of the chassis, just hanging on there on that pulley when I opened it up. But apparently they're totally deteriorated and unglued, and you see they're separating. And they're brittle, they're no longer flexible. I mean, they're ancient, they're almost 100 years old. And this one looks like somebody might have replaced it at some point. I don't know. It's not as ugly as that one. Maybe because it wasn't under the chassis and it didn't get as hot as this one, which would have been in the area that it got hot. And you see it's been sitting a very long time. You can tell by the way it's closed there. It was around that for a long time until it finally let go, and this would have been around the big pulley here. Well, anyway, I found out where this one went. No, I didn't know, but I was trying to tune it to my local station, and there's no way to tune. And so I was looking closer, and I seen this pulley here on the other side of this guy. What this does, I have no idea. It could be this rod here, and I bet it is, because that one's hard to turn, and I haven't been able to get it to turn. Yeah, that's what that is. So that turns that switch in the back. Okay. When I try to turn it, it doesn't turn. But when I try to turn it, and you can see it's worn out where people have been forcing it, it makes my current limiting bulb go real bright, because it's probably shorting out while it's turning with, whatever. But anyway, this belt here went around here and went around that pulley way back there, which you can see in the back there, that brass pulley. That's what turns the dial. It also is what turns the tuning condenser. So to get it close to my local channel here of 1450, I just manually turned that one in there, reached my hand in there, it was very difficult, and turned it around until I got the needle down around 1450, because I know that that's the loudest station around. It's very loud and still no sound. So these, I don't know if I can even find these things. I have to figure out what length they're supposed to be. It looks like, the glue, well, no, it looks like they broke. See, that one looks like it broke off. It's cut at an angle, and it would have went right here, and then it was glued here. And so it was a multi-layer belt. I don't even know what that's made out of. It's just really weird, but it's 100 years old. Same thing with this one. You see how it just let go right here in two sections. This section let go, and then this last piece. So it was 3 layers, well, give or take. One layer let go, then the other layer let go, and the third layer let go. And you can see that's the case on this side here. You got the single layer here, and then you got a double layer here, and then the triple layer here. So it broke it. See the double layer and single layer, double layer, triple layer. So, and I'm saying double, single, double, triple. I don't know. That could be multiple weavings of each layer, but it looks like it's 3. See, it looks like it's 3. If the camera will focus, 3 layers. So again, it's a woven material. Reminds me of old drive belts that they used to make out of leather. It's probably leather. That's probably what it is. I don't know. It could be leather. It's what it feels like, and it seems to me that that's what they used to make belts out of when I was quite young. Well, they were old when I was quite young, so I don't know. But anyway, we'll have to find something that'll work around here and around there to turn the tuning when you turn this. This is the tuning control. And then this, I need to figure out why that don't turn. It's got a very strong spring in there. And then this one, when you turn into tuning, it turns that there, which turns the condenser, but it also spins this gyro over here, this generator of some sort. It's got wires coming in it. It's got some coming off this switch that don't want to adjust. And then it has some there. And I don't know, maybe it is a motor. Maybe when you flip this, it turns this motor on, spins this shaft. No, that wouldn't make no, well, maybe. Spins this shaft to turn the needle all the way back to the other end of the dial. I mean, that's possible. It could be a motor. It's got two wires coming out of the back of the coil there, so they energize the coil. And then it's got two wires here to go in here, and I don't know exactly where they go. I haven't pulled it out. I'll have to at some point. But, you know, I don't know. I don't know what that does. It's not on the schematic. Neither is that set up on the schematic, this thing. So I don't know what that does. And I don't know what the switch is switching on and off. It definitely connects to this, looks like a motor. It definitely connects to that. And maybe that's all it does, is turn this motor on and off and spins this, which would turn it one way or the other, depending on the way, if it's a DC motor, depending on the way the current's going through, it would turn it until it gets to the opposite end of the dial. Then it might have a switch that shuts the power off to here. I don't know. It's coming off the line, which makes me think it's AC. See, coming off here, jump into this wafer switch, and I can trace it out with the ohm meter and figure it out. Well, I guess the next step is to change these capacitors. I really didn't want to do that unless I had some kind of sound coming out of the speaker. I'm not getting no sound. I've checked the tubes are fine. The only thing I could think of is maybe a resistor shorted or a capacitor shorted. So 1, 0, and 4 zeros would be 100,000. So I need to undo one side of that and see if it is 100K. If not, switch it out. It could be drawn. It's only 33 and it's supposed to be 100. It could be pulling voltage down. I need to check all of these. Actually, you can check some of them while we're here. This is a 1K here, brown, black, red. So let's see what we got on that. Okay, that's fine, 1.0K, so that's fine. And this is a 2, looks like, I guess it's a red dot, yeah, so 220K. And let's see what we get there. And we're getting 23K. Now, what if that's, all right, that's orange. That's right, 22K. This is supposed to be, oh, maybe that ain't yellow, maybe that's orange. Orange is 3, which would be K. That makes more sense. The schematic said 100, but 10 would make more sense. That's fine, that's a 10K, yeah, that's fine. I don't know why I was looking at that as 100K. It's brown, black, orange, so it's 10,000 or 10K. And it's registering 13. I mean, it's out of tolerance. This one is, to give you an idea, it's 150. 1, 5, it'd be 15K. 1, 5, and 3 zeros. And it's registering 20K. And of course, it would be good up to 18. So, you know, they are out of tolerance, but not enough to make no sound at all. There's something wrong. It could be a shorted capacitor to ground. There's so many capacitors going to ground in here. We got another dog bone resistor here, which is yellow, 4, 0, and orange, 40K. Cool. Mine the right ones. This one. And that one. Oh, well, that's not good. And I'm going to take that tube out. No, I didn't have any difference. So, we can't measure that one in series and circuit. Where is it going to? Get these wires out of the way. It's connecting here to this wire. So yeah, I'd have to take it out of circuit to verify it. But, you know, to read these, it's body, dot, body and dot. So you can think of bed, B-E-D, body and dot. And so this is 4, that's purple, not black. So it's 4, 7, it's 47K is what it's supposed to be. But I'd have to take it out of circuit to get an accurate measurement, because there's no way that that's 2K, 2 ohms. I mean, that's a dead short right there across those two. And I got the tube out, so why would they have a resistor across something that's dead shorted? I might have found a problem. And that goes to ground, so this is going to ground. And the only thing that could be going to ground through that I see is that resistor, because there is other things in there. There's something there. That's the terminal. Oh, maybe, oh no, it's connected to both terminals. No, it ain't. It's hard to see in there. There we go. Alright, they soldered to the actual pin socket, and then they, okay, so we got a wire coming off of it. That's coming up to this pin here, I believe, yeah, maybe higher. No, it's connected to that pin, yeah. Okay, and then it has this wire coming over to here, which goes to this control. And it has these two capacitors going to ground. So this side is grounded right to the chassis here. You see that? Chassis ground there, connects to this and connects to this. So this side of the resistor is grounded. These two are going to ground. And that wire connects to this one here, this 0.05 to ground. It could be shorted, and that's what I'm thinking. Let's check across and put this on the positive side and this on the ground side. Yeah, let me zero out my meter, but I'm pretty sure that's it. Yep, see? So now, that's ground. Yep. Okay, so this capacitor could be what's killing us here. Oh, wouldn't that be something if I found it, just trying to show a few things on the video. I'm going to just go ahead and clip that one off and see. The other one goes to the other pin, so that's not the one that connects to this resistor. I don't think that goes up to that. No, that goes to this resistor here. Okay, so let me clip that. And we'll clip it up here. Okay, now we'll check across this resistor again and see if we're grounded out. Yeah, so that's probably not it then. Okay, so from there to there, we have nothing. So that capacitor is not the problem. Something in this line is grounding out. Now, the only other thing that connects to that is this wire here going to this switch. And it could be shorted, this potentiometer. Where does that go to? That goes here to here. Which connects to that tube down there. Wait, no, I don't go there. What connects to this? There's only one wire going to that. There's no other wire on that switch. And that's definitely the one going to that resistor. There's nothing else connecting to that resistor to be shorted. This side is the ground side. This should not be ground. This should be higher. And so it didn't get its ground from here. So where did it get its ground from? Has to be this switch. Here. Where is that switch? And why would it be grounded there? Let me try turning. Oh, that turns this local distance. Oh, okay, maybe it shorts it out. Shorts out that resistor there. Let's try that. Maybe that's a bypass for this resistor. No? No, I'm still getting 0 there. This has what? Just 2 settings. Basically, it's the local distance. Wrong thing. Local distance. What else is on that? Off. Ah, there you go. That's where it was getting shorted from. But now we got 38 ohms. Wait a minute. Wires are loose. Now we're still at ground. So this is still going to ground, this wire, which makes no sense. They wouldn't have a resistor here going across 2 pins if there was already grounded. It would make no sense at all. So where else can it be grounded? Oh, there is another wire. Where's that wire going? It's not connecting to that. Nope. That wire. Where's that wire going? It's going to this pin here, which doesn't touch that pin. So there's nothing else on here but that wire. Oh, wait a minute. That wire's going, yeah, it's going to that pin. See a second, it's a cord underneath there. And that goes over to that. And that's the only thing on it besides the tube, and the tube's out. So if this is still shorted, and it is, then we know that this is the problem. I need to cut this wire. Well, I'm going to just heat it and unhook it. I don't think I can get that out of there. Unless it's wrapped around. Yeah, it's wrapped around. I'll just cut it. It's a small wire. I can always replace it. Let's cut that out of there. Let's see, where do I want to cut it from? I'm going to unsolder it. Give me a second. All right, I found out what's going on here. What was going on here. This resistor was in here, across here. Okay? And we were getting a dead short across it. Well, I took the resistor out. It's not shorted. But what was happening was in this way. This side here connects to ground, directly to ground up here, connects to the chassis. This side here was grounded too, but it wasn't supposed to be grounded, so it sounded like this resistor was shorted. There's a wire that goes from here to this pin and over to this socket, and that's the only other place it goes. It goes to this switch. Now this switch, when I tried to disconnect the wire here, I heated it up. When I did the whole thing, tab and all fell off. It was obviously broken off at one point, and they soldered it back on. So when I heated the solder, it just would come off. Well, I soldered it back on. It's on. But that wasn't the problem. I took that off. It was still testing shorted from here to here. We disconnected this capacitor. It's still tested shorted from here to here. That was connected there, which also connected to here. So then I went ahead and took this out. But before I did, I realized that this tab here, this tab in the back there, was bent up more. I bent it down. What that is just like this one here. It's the tab that's part of this ring that goes around the socket that's riveted to chassis ground. So this is grounded. Well, so is this tab. It's the same exact tab. You can't see it from here probably, but it's connected to the ring that goes around. Well, right from the factory, apparently, because I don't think that this resistor was ever changed. That's the original dog bone resistor. At least I believe so. Well, anyway, it was soldered to the very side of this tab. Just barely had enough solder to make a connection on that side of the tab. So basically it was shorting, it was bypassing this capacitor, which was going from ground to there via this wire. This was going from ground to ground because that was grounded, and this resistor was going from ground to ground. So it's a wonder the radio played at all back then. Or maybe when somebody broke this tab, they played around here. It didn't look like this had been resoldered, but it's possible, and somebody accidentally soldered it to that tab. I don't know. But this is the 6K7, and it's a mixer tube for the antenna and oscillator. So no, the radio ain't gonna play without that. Let me show you on the schematic what was going on. So here's the tube. And on the cathode here, we have that resistor that goes to ground. And this side here was also grounded. So this capacitor, this cathode was grounded out to ground. So this resistor was going from ground to ground, and this capacitor, the same one, the 0.05, was going from ground to ground. And here's the switch. Well, the switch was useless too, because it was going from ground to ground. So all three components were shorted to ground by that ring that goes around the tube socket. It had a tab that was touching here. Not supposed to touch there, obviously, but it was actually touching and soldered, which is really strange that this would even work, because like I said, this is the RF. No, I'm sorry, it's not the oscillator. But this is the first RF. So the reception on this radio must have been terrible, because this is the antenna coming in, and this is the grid, and the cathode and the suppressor grid up here were both, the third grid, were both connected to ground. They were grounded through all of this. Whether that switch was on or off made no difference. What this switch does is it shuts these two off. Okay, it bypasses this and does short it to ground when the switch is on. When the switch is off, you have a tank circuit here that separates the cathode from ground, and that's some oscillation. Well, that was all. That whole circuit was shorted out. So we got that fixed. But I don't think that's the problem with the radio not playing, but it is a problem. The resistor itself is out of tolerance, of course, like all these dog bone resistors are. They're not bad. They should play with what we got, but as long as they're not bad. But this one reads, supposed to be 47K. It's 52K. It's not really too far out of tolerance, but it is out of tolerance. So I'm going to put another 47K in its place and connect that capacitor back up. The capacitor is connected here. I'll just jump a wire from, actually I can connect it. You see the wire goes around to here. I can put this resistor back in and I can run, well, I'm going to be changing this capacitor anyway, but I'll put the new capacitor in here, go into there, and this tab, I'm going to bend it down even more so it don't get shorted out, because that's definitely a no-no. So let's bend that tab down. If I can get in there. Okay, I'll bend that down. Yeah, now it won't short out. That's not supposed to be connected there. And somehow it got connected there. And you can see there's a little bit of solder right there on that side where it was soldered to this clump of solder. And well, actually on this one here, which I can bend that back down now that I got the tab out of the way. So that's the tube socket there. So the resistor goes across there. I'm going to go ahead and put the resistor in. It goes across there. And then I'm going to get a new capacitor to go up to here and connect to it to ground. I don't need to come all the way down here to go to ground. You see it connects to ground here through these wires and through this. This is actually the chassis here. It's bent up right there. See it in there? And that's all connected to ground. So what I'm going to do is just put a resistor and a capacitor across each other and connect it here, because this has already got a ground. I'll put the shield side up here and put that resistor and capacitor in correctly and take this one out. We won't need it. And I'm going to be changing them all anyway, so I'll do that as I go. Okay, this is a first for me. I just changed this capacitor. It's a Zenith. It's 0.05 microfarad at 400 volts. Of course, it's bad. Instead of 0.05, it's 0.141. So it's like 3 times what it should be. But what's so unusual about it, or what I've never seen, is it's got braided leads. Now, obviously, that was shielding, but both sides. Braided leads going right into the capacitor. I've never seen that. Now, I know it was in an RF circuit, so it makes sense, but I've never seen it. But anyway, it was 3 times bad, so I replaced it with 1 time good. And I got those done so far. Still working my way. Since this one is in this coil area, I need to figure out what it is. It's 200 volts. Looks like it says 0.3, cap 0.3. And it's got foil in it, showing right through. It's a Cornell capacitor. And it just says cap 0.3, which makes me think that it's a 0.3 microfarad capacitor. Never seen one marked that way, but I got to replace it. It goes to ground, so I'm going to find it on the schematic. This is the ground side, 200 volts. Oh, it broke off. It don't matter. I'm going to change it anyway. And that's just an interesting capacitor too. Actually, let's see what it measures while I'm thinking of it. We'll put this here. Turn this back on to capacitance. I'm running out of room on my desk here, on my bench. Okay, let's go to capacitance. Alright, and we'll see what this joker measures. I can clip on it. I take 2 hands. Okay, I'm on it. and it reads 0.05. Sure. So yeah, it's a point. It's a point. What did it say it was? 0.3. And it's 0.005. No, I'm sorry. I take that back. It jumped up to the microfarad scale. This joker's reading 5 microfarads. And look, it's jumping all over the place. Wow, 5 microfarads. But that definitely says 0.3, not 3. And they didn't have any 5 microfarad capacitors. This would be an electrolytic. Well, it does have a ground side. 0.3. That's so weird. So I have to figure out what to do about that, because obviously 5 microfarad is a whole lot more than 0.3. That's got to go. I've been all over the schematic, and this thing here just wasn't in here. So, and it makes sense that it wasn't in there, because, I mean, it is old, but it's a Cornell, and all the other ones are Zenith, with the exception of this one here, which is not a Zenith either. So it was a replacement. It's a INCCO. Don't know what that is. It's going to the same coil, and it's a 0.001. There's no 0.001 on the schematic. So that one's been changed. Up here, this brown one looks different than the other orange one. But it looks like it's a Zenith, so we may have just discolored. But this one, that thing was over here. I'm going to leave it out till I know what to put in there. I have one I can put in, a 0.3, but I ain't putting that in because it's not on the schematic. And I went nuts tracking that down. So what I'm going to do with this is just coil it so that I know that it was the one that went to ground. Of course I got it on this video. So I think I did everything I can do so far, other than start changing more caps. And troubleshooting is a slow process, but I'm going to see if what I've done, and unshorting that, makes a difference and we get a sound out of this radio. If not, I'm going to leave it for tomorrow, because I've already wiped my brain on it. I may print out this schematic and put the values, because by the time I find something up here and scroll down here and look at what I'm looking for and then scroll back, I get confused because they have like 1, 2 C8s, they have 3 C5s, and one here, and so they have duplicates, C10, C10, and so, you know, when you come down here and then you come back, you end up looking at the wrong one, and oh boy, I tell you, it's just strange the way they did this schematic. And by the way, that motor is on here, and it is a motor. They got a coil for it here. Still don't know what it does, but it's there, and they're saying that it's a motor here. So I don't know what the motor does. And surely, if it spins this thing, it's going to spin that, which is going to spin the tuning control, and it has to have a shutoff or it would spin it beyond belief. So we may not need that if we can get a connection from here to there and just turn this by the knob to turn the stations, which makes more sense. If I can get that going, fine, but right now I'm just worried about getting the radio going. And this motor's not spinning, so I don't know if it is a motor, why it's not spinning. But we'll figure that out once we get closer to it. Right now I need sound out of this radio. So that's where I'm at. Thanks for watching. Okay, I was right. This this has a motor that spins from one end of the dial to the other. And so this knob here, which I couldn't turn by hand, if you turn it one way, you see the motor spins one direction. Turn it the other way, it spins in the other direction. I wasn't playing with it too much because when I try to turn it, you see what it does to my light. But you see it's a lot brighter on the camera than it is in reality. But the reason the light's going bright is because it's also dimming. You see it's dimming the pilot light because that motor needs servicing. But the motor's working, so that's why it was glowing. But I still don't have any sound coming out of the speaker. So we know what that does. That turns the shaft, which turns the control up there. And this is fine tuning. So you turn it really slow, the motor would turn it for you and you don't have to keep turning it to tune your channel. But we still are not getting any sound out of the speaker. Now when I turn that, I get some click click out of the speaker. So it's obviously putting a strain on everything, like the light, my current limiting bulb, and the speaker coil. But I don't understand why I'm not getting any sound. Speaker's connected, the antenna not doing nothing, and it's on. So there should be some sound. And I go to distant, no different. This is the potentiometer for the volume. So did that turn it off? No. But that clicked. I don't know what that did, but it clicked. Oh, it's much easier to turn it one way than the other. Probably should put some knobs on here, so I can turn these things. Okay, that's all the way volume. This thing here, I don't know, normal, high fidelity, bass. Okay, that's the tone control up at the top. But I'm getting nothing. Take that back. I wasn't getting nothing earlier. I'm getting some sound. I'm going to set up and run a 455 kilohertz signal through there. I don't know what the IF is, but well, maybe I'll find it on the schematic. I'll be right back. Okay, so tomorrow we're going to finish recapping this and then see what happens. And I should make it better. At least I'm getting some sound. That's a good thing. Not getting any real good sound, but I got sound. So tomorrow I'll continue, and or in the next video. So in part 2 we'll have finished recapping. We'll recap and we will figure out this motor, see if we can get this radio to play. So anyway, that's where I'm at. I appreciate you watching the video so far, and I hope it's been informative. We've seen how to troubleshoot a radio, and even one that's had a work done to it. The transformer's been replaced, and we don't know what they put in, but we're assuming it works. We found some capacitors that were changed. We replaced the electrolytics, so we're doing pretty good. This is the first run on this radio, so appreciate you watching the video. If you find it interesting, give it a thumbs up, and we will continue it tomorrow. We'll continue this video soon, part 2. So if you found it interesting, consider giving it a thumbs up, and don't forget to hit that bell, and you'll get notifications as we add to this restoration process. Thanks for watching. I hope you have a good day.